Good day, grade 7 learners, and welcome to Tele Mat Aralan. Today's topic is the continuation of our previous topic, operations on set. Our topic for today is lesson 4, properties on operation of integers. Learning objectives. Illustrate the different properties of operations on the set of integers. Closure, commutative, associative, distributive, identity, and inverse. Closure property. This is applicable only on addition, subtraction, and multiplication. Let's recall first the notation of set of integers, which is the bold letter Z. Take note, capital letter Z. Illustration. Positive integers are the numbers to the right of 0, which are 1, 2, 3, and so on. To the left of 0, negative 1, negative 2, negative 3, and so on, which are called negative integers. Let's continue. Closure property on addition, subtraction, and multiplication. Any two integers being added, subtracted, or multiplied to each other will only result to an integer. Illustration. For any a, b, and c element of the set of integers, a plus b is equal to c. Take note, a here is an integer plus another integer will result to a sum which is also an integer. Next case, a minus b is equal to c. A and b are all integers. When subtracted with each other, the result or the difference is another integer. Same is true with multiplication. A times b will only result to a product which is also an integer. For example, 7 plus negative 5. 7 is an integer added to another integer will result to an integer, which is 2. Another example, 4 minus 9. 4 and 9 are all integers, will result to negative 5 when subtracted with each other. Negative 5 here is also an integer. In multiplication, 6 times negative 7, wherein both 6 and 7 are integers, will result to a product which is also an integer, which is 42. Commutative property on addition and multiplication. Take note, commutative property is only applicable on addition and multiplication. Let's see what is commutative property all about. It says here that order of addends does not affect sum and order of factors does not affect product. Take note, for any integer a and b, a plus b will also be equal to b plus a. It says here, order of addends. Where are the addends here? A and b. Even if we reorder the addends, b plus a, the sum will still be the same. In multiplication, order of factors does not affect product. Shall we say a times b is equal to b times a. Even if we reorder a and b as the factors, the product will still be the same. For example, 7 plus 5. By commutative property of addition, 7 plus 5 is also equal to 5 plus 7. Let's double check. 7 plus 5 is equal to 12. And 5 plus 7 is equal to 12. So 12 is equal to 12. It is true now that order of addends does not affect sum. Another example, 4 times 9, which is by commutative property on multiplication, this is also equal to 9 times 4. Let's double check. 4 times 9 is equal to 36. 9 times 4 is also equal to 36. This shows that order of factors does not affect product. Next property, the associative property on addition and multiplication. Take note, associative property is only applicable on addition and multiplication. This states that grouping of addends does not affect sum and grouping of factors does not affect product. In our commutative property, order does not affect sum and order does not affect product. Let's see the illustration. For A, B, and C elements of the set of integers, A plus the quantity B plus C is equal to the quantity of A plus B plus C. The groupings here on the left part of the statement is that B plus C. On the right part of the statement, A plus B. In multiplication, grouping does not affect the product. In this case, A times the quantity B times C is also equal to the group A times B times C. The groupings on the left part is B times C, and the groupings on the right part is A times B. Let's see these examples. 7 plus the quantity 5 plus 4. By virtue of associative property on addition, this one is also equal to 7 plus 5. Its quantity added to 4. Let's look at the grouping here. The group on the left part is 5 plus 4. And on the right part, 7 plus 5. So now let's double check. In operating quantities like this one, the quantities inside the parentheses should be operated first. 5 plus 4 is equal to 9 plus 7 is equal to 16. Let's check the other side. 7 plus 5 is equal to 12 plus 4 is also equal to 16. Next example. 2 times the quantity of 4 times 5. By virtue of associative property on multiplication, it is also equal to 2 times 4, its quantity, times 5. So let's double check. Let's operate first the quantities inside the parentheses. 4 times 5 is equal to 20, times 2 is equal to 40. 2 times 4 is equal to 8, times 5 is equal to 40. Next property, the distributive property of multiplication over addition and subtraction. This states that multiplication is distributive over addition and also to subtraction. To further understand this, let's see this illustration. For any A, B, and C element of the set of integers, A times the quantity B plus C is equal to the quantity A times B plus the quantity A times C. This is also true in subtraction. A times the quantity B minus C, by virtue of distributive property of multiplication over subtraction, this will become A times B, its quantity, minus A times C. To further understand this, let's see this example. 7 times quantity of 5 plus 4. By distributive property, this should be equal to 7 times 5 and 7 times 4. Let's see. 7 times 5 and 7 times 4. But wait, let's look at the operations in between these quantities. It is positive. Where did we get this one? This positive or the addition sign here is from this operation here, this plus sign here. So let's double check. 5 plus 4 is equal to 9 times 7 is equal to 7 times 9. 7 times 9 is equal to 63. Let's double check the other side. 7 times 5 is equal to 35 plus 7 times 4 is equal to 28. 35 plus 28 will result to 63. Indeed, distributive property of multiplication over addition is true. Let's see this other example. 9 times the quantity 5 minus 4. This should be equal to 9 times 5 minus 9 times 4. 9 here is distributed inside the parentheses. 9 times 5, take note, and 9 times 4. Where did we get this operation here? The operation in between 5 and 4. Let's double check the first side. 5 minus 4. 5 minus 4 is equal to 1, and let's bring down 9. Now, 9 times 1 is equal to 9. Let's double check the other side. 9 times 5 is equal to 45 minus 9 times 4 is equal to 36. So, 45 minus 36. 45 minus 36 is simply 9. And indeed, distributive property of multiplication over subtraction holds. That's because 9 is equal to 9 in this example here. Next property, identity property of multiplication and addition. Identity property of addition. Any number added to the additive identity 0 is equal to the number itself. What does it say here? Let's see this illustration. For any x element of the set of integers, x plus 0 is always equal to the number x itself. Remember, any number added to 0 is always the number. For example, negative 5 plus 0. By virtue of identity property on addition, any number added to 0 is always the number. Negative 5 in this case. Next property, identity property of multiplication. Any number multiplied to the multiplicative identity 1 is equal to the number itself. For illustration, for x element of z or the set of integers, any number multiplied by 1 is the number itself. In this illustration, x times 1 will always be equal to x. For example, negative 3 times 1. By virtue of identity property on multiplication, negative 3 times 1 will always be negative 3. Or any number multiplied by 1 will always be the number. Next property, inverse property on multiplication and addition. Inverse property on addition states that any number added to its additive inverse is equal to the additive identity 0. Or in short, any number added to its additive inverse is equal to 0. But by the way, what is additive inverse? Additive inverse may be understood using this illustration. For any x element of z, x plus negative x will always be equal to 0. What is our negative x here? This one is our additive inverse. Let's have this example. 5 plus negative 5. Negative 5 here is the additive inverse of 5. So, any number added to its additive inverse will always result to 0. Inverse property on multiplication. This states that any number multiplied to its multiplicative inverse is equal to multiplicative identity or 1. To further understand this, for any x element of z, x times 1 over x here is our multiplicative inverse, will result to 1. Remember, 1 over x is our multiplicative inverse. Having x as our denominator and putting 1 as its numerator. And that will become the multiplicative inverse of x. For example, 4 times the multiplicative inverse of 4, which is 1/4, will become 1. That's all for our lesson 4, properties of operations on integers. Number 1, closure, commutative, associative, distributive, identity, and inverse. I hope you've enjoyed learning with me today. And once again, I am Sir Jim saying, just watch and learn.